Good afternoon, students. So welcome to today's class. Today we will see about the extension to the functions, which we see earlier in earlier class. That is, how can we define a function, and how can we define a function without argument, and how can we call a function with a return statement and with return statement, and what are the different types of structures available to define a function, and how the function that can return the values if we are not having the return statements. So different types of examples already they have been executed in our lecture. If you go through the video, then you will know how can we execute the sample snippets of in our function. And today also we can continue the R functions with other extendable features. Those are nothing but that R functions can support pointers, and R functions should return which type of values, and what are the other built-in functions which we will use in user-defined functions, and recursion and other extendable features like R. So the next one is how R should return complex objects. So R can return any type of return values, that may be integer, character, or any other. So that may be any data. But similarly, R should return complex objects also. So the return value can be any R object. You can return complex objects also in R. So here we are having a simple example. How this function defined with complex parameters or arguments should return the complex objects as the return value. So here we are defining a function, it means g, and passing a parameter, a value to parameter x or argument x. But function is not defined with arguments. X is a local parameter here, local argument. And t is calling the function itself with a value and returning x square. So return t value. So here we are defining the variable as local, that is x, and calling the function. This is nothing but nested functions. So here we are defining another function p within function g with some return value. So when we call g, that is nestedly, g function can call t by passing the value x, which is 3, and returns the value, that is cube of x, or if that is a complex number. So the function x returns x square. So environment is the hexadecimal value. If the function has multiple return values, then we can place them in a list or in other containers, that is an array or a vector or any other. That is, if there are multiple values. If there is a single return value, that will return the value. So we will try this one in our console. And paste this in our console. Function g defined without arguments, and next creating the local variable x, and creating another nested function p with this local variable which can return the value exponential x. So here simply you can call this. So function x which returns x square. So environment is 0x, that is a hexadecimal location where this value can exist. So if we can call the what is the return? X is missing, there is no default value in the function. So if we call g, then only we can get this result, because we can call internally the local variable. If you can call t, there is no value passed to x. So this can produce n. So this is nothing but how can we create the nested functions. So if you can create any value here this is this time this result means that is the accepting the local value 3 and putting that value in this environment. These are nothing but complex objects means displaying the results in hexadecimal form. So this is written in the complex object. So if the function has multiple return values, then we can create an array and place those in the array. Container means maybe array vector or any. Next, what are the functions? Whether these functions are objective or not. Our functions are first class objects of the class function, meaning that they can be used for most objects like other objects. So this we can see this in syntax of the function. Syntax of the function is function name, function with arguments or without arguments and with return value. So these are nothing but objectives. So functions are always first class objectives which can produce any R objects as the return values. So within the syntax of the function itself we can identify functions are objectives. So function is a built-in R function whose job is to create functions. So here function itself is following to create multiple set of functions. We can use the function, built-in function is your word which can create multiple set of functions in nested manner. On the right hand side there are really two arguments to functions. The first is the formal argument list for the function that is x, and second is the body that function returns. So x plus 1 return x plus 1 is the body and x is the argument which is a formal argument. Second argument must be a class which is an expression. So x plus 1 is an expression. First argument, formal argument is nothing but a variable. So the point is that the right hand side creates a function object which is then assigned to C. So here that is nothing but creating a function object and assigning to G. So its job is making a single unit of what could be several statements. So formals reserved word. The purpose of this reserved word is get or set the formal arguments to a function. So formals of G. G is the function with formal arguments. Right? So formals of G means $x. So you can see by executing it. If you simply type formals, whether what is the result you can display. You can see. So here we can type. So here you can see formal. That is the value. So here that is displaying null. So if you can write this one. By putting this one, here is formula. What is the value? So because G is not having any arguments, if G is having any arguments x, then it will be only value x. Because here you can see the arguments we are passing to a function should exist in the function which is mediated. But for g there are no arguments, so that is written in value. Instead of that, if we simply pass a function g, it's a value that is with some argument function is with argument x, and we can return x less than. Okay. If we type formal here, and what is the return? So here you can see. So the argument we are passing x itself is the formal argument if there are arguments. If they are not having any argument, we should return null. But x is nothing but a actual argument here. The variables are arguments which are available within the function. Those are actual arguments. If those are existing in the function definition, those are the formal arguments. Because formal arguments means based on allow to and fro data. And next one, that is the formal function. Next, what another function which is used to get or set the body of the function. So again we can type what is the result of body of G. What is the body of G? So that is nothing but begin return x plus x. Yes. So this is written in the body of G. And another one. Next function, replacing body of the function with code function. We use the substitute expression. That is code function that can be directly used to replace the statements available in the body with another one. So here, that is here we are replacing the function x return x plus x, then body of G is assigned with the code function 2 into x plus 3. Then again we can display the G, what it should be. So here we are assigning body of G with the code function. This is nothing but substitution function. 2 into x plus 3. So here you can write. So that is the function x with some value 2 into x plus 3. So the body is changed. The existing body return statement is replaced with a new one, that is 2 into x. So code function is used to substitution of the existing functions with new values. So this is the code function. So three function formals, that is always displaying the set of formal arguments we are passing through function name, function reserve, that is in function arguments list, and body is displaying the structure of the statements after the function name and function argument. And code function is used to substitute the existing body with a new set of expressions. And next, typing the name of the object results printing that object and which is similar to other object. So printing out a function is also useful if you are not quite sure what in your library function does. So code of the function is displayed by typing the built-in function name xd. So if you want to know the code of the function, so then you can type the command xd, that is nothing but the structure definition that can display the structure. So here you can see the xd function format by using the xd command. So we can implement what is the command. So function x, that is the structure with set of arguments, and next square root or is factor or etc. This is an example format. So this is displaying the structure of the function. And next, some of the are most fundamental built-in functions are written directly in C, and thus they are not viewable in this manner. So some built-in functions are available in C format. So those are not directly visible on the R console. R can display only the functions which are defined in R structure. So the functions which are available in C format, C language format, but do not display the structure of codes. So, for example, if you want to display the sum function structure, then simply you can type sum. So function primitive. So this is not producing the complete structure of the function, which is simply giving the function with the unique format, that is with the default format. But that is not producing the any extendable format of the functions which are available in C structure. This is producing the function formats which are available in R structure. Next, since functions are objects, you can also assign them, use them as arguments to other functions and so on. So F1, so here you can see F1 is a function which is defined to return the sum of A and B, and F2 is a function defined to return difference of A and B. And here I am assigning F1 function to F, and F is called with two values 3, 2. So the result is 5. So G is defined as a function with H, A, B. And here I am calling H is nothing but another function object, not a parameter. Another function object which is called recursively in the defined function, which is called with the function names which are already defined. So the function names which are already available are F1 and F2. So here I am calling F1 with 3, 2. Then this can display the result 5. That is calling a function within another function. And similarly here you can call with F. So when I am designing a function, by considering one argument of the function as another function definition, those are called nested functions. So here when I am calling G, that recursively calls F1. So this is when I am calling F1 and this is when I am calling F2. 2 minus 2 is 1. When I am calling F1, 3 plus 2 is 5. So we will execute this. And here we can type in new F1 is assigned the function B, which is written in return address. And next initially we get F1 function A, B return A. So here I am assigning F2 F with F, and when I am calling F with arguments 4, 5, the result is 9. So here I am defining another function H, A, B So here is I'm calling the function. So h means that it has to be counts. What are the few functions which are already defined earlier? So here I am calling G with the earlier function definitions F2, comma. So F2 is transferred into H. Then automatically H is going to F2 and passing reality to that. So 6, 7, F2. Okay. And again I am calling G with F1. The same value 6, 7. Minus 7. So 6 minus 7. So this is nothing but value function. We define the function nested functions and call it the nested function. So that is it. And next coming to pointers. R cannot support any pointers like E. So R does not have variables corresponding to pointers or references like E. This can make programming more difficult in some cases. The fundamental concept is to create a class constructor and have every instantiation of the class be its own environment. One can pass the object or condition into a function and it will be passed by reference instead of passed by value. So you already know passed by value and passed by reference. Passed by reference means that is referring the address location of the variable where that argument is available in the memory. That is passed by reference. Passed by value means getting the actual value of the variable instead of the address location. So this is always used in pointers because pointers always refers using the address instead of value. But here R cannot support pointers. So this always cannot support the reference. This is always supposed to passed by value because unlike other objects, environments are not copied when passed to functions. So change to the object in the function will change the object in the calling frame. So for the 20 here, this cannot support any because pointers refers extra memory location which can internally pass to references which changes the environment. So in this way, one can operate on object and change internal elements without having to create a copy of the object when the function is called. Now, pass the entire object block from the function. For large objects, this saves the memory as well. So, references means multiple references of the address location. This leads to memory wastage. Already we know if we are using the pointers means that leads to memory wastage. So, for prevention of this and saving the memory and time, R cannot support any pointers. For example, you can write a function that directly changes its arguments. So, for example, here I am creating a vector with 3 values. I am directly calling sort x that can display sorted list but that cannot store that list. That is nothing but sort of x, but after calling this one, we can see 6, 12, 45. But when I am displaying x, that is again displaying the same value. There is no reference to the address location where this vector is available to replace with new values. So this is nothing but constant value only, not the reference. So what are the changes we are making in the code that should not reflect in the actual values of the variable? So because there is no references of the pointers or addresses or any other. So the argument to sort does not change. If you do want to change the x, then you can directly assign sort x to x itself. Then the values can be changed. So this cannot directly allow any references to memory addresses. What are the values available in the memory? If you are allowing the references, that can be indirectly changed when you have referred that address location. That leads to a lot of complexity in implementation. So that R cannot support any pointer reference. If a function has several outputs, then the solution is to gather them together into a list, call the function with this list as an argument, have the function return the list and then reassign to the original. So we can see an example here. An example here is determining the indices of even and odd numbers. Indices means index positions of even and odd numbers. We are creating a function with a vector v as an argument. And here odds is a parameter, a vector which is vector modulo 2 is equal to 1. So can be transferred to odds. And evens percentage modulo 2 that is equal to 0. Then evens which returns the index positions with function, not the actual values. So list of O equal to odds, E equal to evens, then you can display O and so we can type this. So creating the function 1, function with vector v, odds, which function returns indexes of odd numbers, and even returns the indexes of even numbers, and storing both those in list with new values. Here I am creating a column vector. You can create anyone. Y 3, 5, 6, 8, 9. So why should we call the function should be called function function. Which are we one and we art list is first number is art and fifth number is R and sixth number is R. Second, third and fourth are zero. So this is nothing but how can we define a function without any reference parameters. So following the function without any pointer that will directly display the original values of the variables instead of reference. And next coming to recursion. What is recursion? Recursion is a programming technique in which a function falls within itself. Already we know the recursion. But how can we use the recursion in R? By itself repeatedly for getting some input. But the common example for recursion is nothing but the backward. To solve a problem of type X by writing a recursive function, we can write a recursive function like a normal function. Break the original problem into one or more smaller subproblems. Within F, call F on each of the smaller subproblems number of times. Within F, piece together the results of B to solve the original problem. So here we can see the function recursive function. This can be called recursive. That is, we are calling the function name recursive within the function body itself number of times until the termination condition is reached. So we have to specify a termination condition in the function. So here recursive function to find factorial recursive dot factorial function x. If x is equal to 0, this is the termination. When x reaches to 0, then that should return the value 1 and terminate. Until that, it can continue calculating the value. So recursive factorial of 5 is 120. So initially we are calling it 5. X is 5, but if that is not equal to 0, then call again 5 into recursive factorial of 5 minus 1, that is 4, and again call 4 into recursive factorial of 4 minus 1, 3, and next call 3 into recursive factorial of 3 minus 1, 2, and next 2 into 1 recursive factorial of 1. When that reaches to 1, again calling when factorial of x that reaches to 0, then this is equal to 0. Okay? So we can see this in this slide. So here we are calling factorial of 4. So return factor of 4 into factor of 4 minus 1, that is 3, because x is equal to 4, not this way. And again call return factor of 3 into factor of 3 minus 1, 2, and return factor of 2 into, so here this is calling and this is return. So again calling 2 into factor of 2 minus 1, 1, and here 1 into factor of 1 minus 1, that can return 1, and here 1, 1 into 2, 2, 2 into 3, 6, 3 into 4, 6 into 4, 20. So this is how we can call recursion. That is similar to other recursive functions we are defining in C and other programming language. So this is the functions, but here there are two applications for functions in your syllabus, that are how can we apply it and call the function, how can we use and call the functions into different types of sorting and fetching techniques. So we can see in tomorrow's class that are the two example applications, binary search and quicksort. We can see that how we can design binary search and quicksort applications in R using the functions. With that, your second unit finished. So tomorrow we will see both the two methods and we can complete the second.